Okay, in this video we're going to talk about partial fractions, and it is often helpful to break down a complicated algebraic fraction into a sum of simpler fractions actually, and that's what partial fractions for. So what we've got here, we've got 9 minus 4x over 3x squared minus x minus 2. So we want to kind of decompose it and break it down into a little bit more simpler fractions. As we can notice here, we look at the partial fractions are actually when the numerator has less power variable, the power of the variable, which is x in this case, the highest power of the numerator is less than the highest power of the denominator, which is the case here, and that makes the partial fraction proper, which means it can be decomposed. And the ability actually to express fraction as its partial fraction is particularly useful in the study of Laplace transform, Z transform, control theory, and integration in these topics in electronics. Anyway, the first thing we should do when doing the partial fraction is we factorize the denominator, which is the quadratic expression here. So we end up with 3x and x to get 3x squared, and in this one we get 3x plus 2 and minus 1. So now we factorize the denominator. After that we rewrite the fraction again, but in the new version with the quadratic equation. So that will be 9 minus 4x over 3x plus 2 x minus 1. So the idea is, once we have things factored, notice that we've got two linear factors here. We want to break them down into two separate fractions, simpler fractions. So what we do is we first choose the first piece of the denominator plus the second piece of the denominator, and the numerator of them is 2 constant. And what we're trying to do here is we're trying to figure out numbers for a and b, that if we make the denominator common, we will get it back to the original fraction. There are actually a few different ways to solve this, but what I like to do is I just simply multiply whatever is in the denominator, this side from both sides, this side and this side. So after we multiply the denominator by this, obviously we'll get rid of it, so we're going to be left out on this side, on the left side, with 9 minus 4x, and in this side, when you multiply the denominator, we'll be left out. We'll multiply both sides by the denominator to obtain the equation from which to find a and b. We're left with a x minus 1 plus b 3x plus 2. So each one goes to the other, multiply with the other denominator. What we're trying to do now is substitute an appropriate value for x to obtain a and b, but we have to do it individually, obviously, because we need only one unknown, not two. So what we do here is we equated a with 0, and to do that we set x equals to 1, so this whole term equals to 0. So we literally substituted all the x's here with 1. So 9 minus 4 times 1 and equals to a times 1 minus 1, which is 0, so a times 0 is actually 0, plus b times 3 plus 2. Sorry, I'm running out of space here. So what we left out with, if we were to solve this, 9 minus 4 times 1 is 4, so 9 minus 4, which is 5, equals to b times 3 plus 2 is 5, so we'll end up with 5b. So what we'll found here is 5 equals to 5b, which means that b equals to 1. Now we're going to do exactly the same thing but with a. To get a, we have to get rid of b. So what we did here is we equated what is multiplied the parentheses with 0. So to do that, we have to make x equals to 2 over minus 3. So to get rid of the b. So in this case, we just literally substitute every x with 2 over minus 3. Now that we substituted all the x's with 2 over minus 3, this is how it broke down. 9 minus 4x, we substitute x with 2 over minus 3, equals to a times 2 over minus 3 minus 1. We'll end up with minus 5 over 3. And if you actually simplify that, we get 9 plus 8 over 3 equals to minus 5 over 3 times a. And if we combine this together, add this together, we get 35 over 3 equals to minus 5 over 3. And if we were to get a on its own, we have to divide over minus 3 over 3 on both sides. You can do that using a calculator. You end up with a equals to minus 7. So what we've got here is b equals to 1 and a equals to 7. So now that we've got our values of a and b, we can literally substitute the original partial fractions that we did, a and b, the partial fractions. We substitute it with the values of a and b that we've got, which is minus 7 and plus 1 and positive 1, and that's your final answer. So this original fraction, we can do it in partial fraction, factorize it or simplify it, and it will turn to this: minus 7 over 3x plus 2 plus 1 over x minus 1. If you were to make a common denominator of these two partial fractions, we're going to revert back to the original fraction.